Hello, this is Colin Lobo, Executive Vice President of Engineering with the National Ready Mix Concrete Association. This presentation outlines some basic quality control concepts for ready mix producers and resources that would be available from NRMCA for producers. It is supported by the Small Producer Council of the NRMCA Membership Committee, and while the intent is to provide some general information for smaller ready mix producers, these concepts may provide ideas to larger established concrete producers also. The basic premise here is that quality control should be considered as an important activity for ready-mix producers and requires some investment in time and personnel. It is an important factor, besides good service to your customers, that obtains and retains your customers. Concrete supplied should comply with the purchase order, that's the basic premise, the project specifications, and in many cases, the customer needs. Concrete supply should also be consistent from load to load. Quality control activities can help identify reducing the producer's costs and maximizing profitability, so it can be justified expense. Ideally, quality control activities should be proactive in the sense that you should ensure that concrete that is delivered meets the customer's requirements and any defective concrete is identified before it is placed. The time spent in troubleshooting problems after placement should not be considered a quality control activity, and time spent should be minimized. It is often said that the responsibility for quality involves all personnel in a ready-mix concrete company. That includes the front office, purchasing, sales, operations, regulatory compliance, order takers and dispatchers, plant operators, and the technical service personnel. They all play an important part to delivering a quality product, and their responsibilities should be clearly identified. It is understood that in a small company, there may be personnel who perform many of these activities individually. So let's get started with the presentation. Some of the NRMCA resources that are available are outlined in this link, and we will go through some of these resources during this presentation. The NRMCA works through a technical committee referred to as the Research Engineering and Standards Committee. This committee has developed this quality control guide for ready-mix concrete producers. That's a good resource that outlines the basic essential items that should be in a concrete producer's quality control program. The quality management system is a more comprehensive document that can be developed slowly by a ready-mix producer, but it goes through several aspects of quality and tries to assign responsibilities to different personnel within the company. We will discuss some of these other resources as we go along. These are some formal definitions of basically what we call quality control and quality assurance. In general, quality control are activities done by a producer to ensure that the concrete meets the requirements of the project, both for fresh concrete as needed by the contractor and for hardened concrete in the structure as needed by the designer of the structure. In this concept, the focus should not only be on achieving strength requirements, even though that is the primary basis used for acceptance of concrete. Quality assurance, on the other side, is the general activities done by the purchaser or the owner to ensure that the concrete supplied to a project complies with the purchase order or the specification. In some cases, quality assurance also is the documentation internally done by the quality control processes to document to management that the company is achieving its quality goals. So that's general difference between quality control and quality assurance. These are some of the factors that influence the concrete quality. We need to make sure that we are selecting the right materials from the right supplier and that we have some control on the variability of the materials that we use in concrete. We should not select suppliers only for cost. We should also select them based on the quality that they supply and the support that they provide to manage their materials. Concrete producers have to develop mixtures for a wide range of applications from low strength, high durability. We need to establish mixtures that meet the different requirements for different applications. We also look at the point of developing mixtures to minimize cost and to achieve the required performance. Production processes involve checking or making sure that the scales and the other devices for measuring materials are accurate, that when we batch concrete, we are batching materials accurately. This is important both for inventory control and for the performance of the product, as well as the cost to the ready-mix producer. That also involves maintenance of different components of production and the operational activities such as working stockpiles, etc., during the production process. There are several other conditions that have to be considered by a ready-mix producer in terms of temperature, ambient temperature, seasonal variations in temperature, distance to the job site and maintaining slump and without adding too much water. Placement and consolidation methods might have some impact on how we proportion mixtures. You may have to do different things for pumping concrete, for flat slab trowel surfaces, etc. And then eventually we have to look at curing and protection of the structure during the construction process. So some general goals. This is a statement given by a concrete producer at one of our sessions. It says that if you have an effective QC program, you simply won't have as many problems. And in having an effective QC program creates more time than it takes to implement that program. So that's a basic premise that you should consider. So in general goals for quality control, do you know what you're putting in your concrete? In terms of, do you know the characteristics of the materials that you are using? And do you know how much you are putting into each batch, whether you're being accurate in your batching process? After you make your concrete, do you know how it performs in terms of slump retention, air content, temperature, slump retention over time, and then eventually things like yield, strength, and any other durability properties that are needed? When you batch different loads of concrete to the same customer, are you consistent between loads? This is very important for some applications, especially for slab construction, where you cannot have much variation between loads, especially on set time, bleed rate, and those sorts of aspects that impact the finishability of that type of concrete. In general, you should consider that it's more effective to avoid delivering bad concrete than to troubleshoot that problem after it's delivered. It also is more expensive to troubleshoot the problem after it's in place. The other types of decisions management needs to understand are to identify what factors that you can manage to minimize variable concrete. There are so many sources of variation that impact the variability of concrete, and you cannot address all of them. So pick some factors that you can reasonably manage to minimize the variability of concrete, because minimizing the variability of concrete minimizes your costs and supports customer satisfaction. The other factors, as when you develop your mix, what factors can you choose to minimize the cost of your mixtures? So we will have, in general, these are the types of scope of quality control activities: sampling and testing of your materials, and then when you make your concrete, testing the concrete. Control of the production process, procurement of resources that will improve your quality. How do you optimize mixtures? Do you have to use 800 pounds of cement for 3,000 psi concrete? Or can you reduce that? Naturally, cement represents your highest cost in your concrete mixture. When you get orders and specifications, is there a review process to make sure that everything that is needed in that order or specification is understood before concrete is developed and delivered? Do you have a process for field control? And some of this may be more for higher specification type work in terms of developing new types of mixtures for different types of applications, etc. So this is generally the scope. Let's take a little look at the general cost. This is developed from the NRMCA annual performance benchmarking survey. So NRMCA annually facilitates this survey and publishes a report. This is a financial survey, but it's also useful to understand where your costs are and how your profit margin can be impacted. So this chart compares average costs of a typical member who participated in the survey, the average selling price, how much does the materials cost, how much does delivery cost, what are the plant costs, what are the fixed front office costs, and what is the average profit. This is also compared to the more profitable producers, the upper 25 percentile or percentage of the profitable producers. How does that compare in terms of their profit margins being higher? How are they varying their cost structure and to the lower profitable producers? So you can see that there's a difference in sale price and there are some differences in their costs. The point here also is that materials represent 50 to 60% of the cost of percent of your sale price. So that is a big portion of the pie that if you can reduce your material costs, you can improve your profitability. You also have other personnel in your company that impact your cost. And all should be aware of how they can impact their cost and reduce their cost to improve profitability. So take a look at this performance benchmarking survey. Within each category, there are several line items that are also there so that you can get some ideas as to how do you monitor costs and establish pricing for your concrete. NRMCA also has on its website at the quality section a tool that was developed by a developing industry leader group as to how you might quantify the cost of poor quality. This spreadsheet can be used internally by a company to identify the dollars per cubic yard related to the materials. If you get bad materials, what the impact is. What is the impact of batching or other issues at the plant? What happens at the job site and other internal costs? And eventually you will get a dollar per cubic yard related to the quality or cost of poor quality, and the intent is to minimize that cost. And sometimes it may need an investment in resources or people to reduce that cost of poor quality. So take a look at that, see if that can help you in your journey to quality. Ready mix concrete is a people business, so you need to have proficient and qualified people to do the necessary jobs to ensure quality. We recommend that you develop clear job descriptions as to the different functions that you want to hire people for, and then try to hire people consistent with those defined job descriptions. There needs to be some internal training. All people that you hire may not be familiar with our industry, and you may have different resources available from NRMCA or internally or with your suppliers that can provide the necessary training to your hires or new hires. In some cases, you may have to consider contractor education so that they handle your product properly and put it in place properly in place. These are the various job functions that may need some training programs. NRMCA has developed training programs as well as certification programs for various of these job functions. So take a look at this section of the NRMCA website that can give you an idea of some of the internal training programs as well as online offerings that can be used on demand. NRMCA also has a one-day pretty comprehensive course on improving concrete quality. This course can help you establish some quality goals that you can then monitor that make sure that you're achieving. Processes for monitoring the variability of the various materials, the impact of batching accuracy, the importance of controlling water added to the concrete mix, impact of delivery time and temperature, how does testing affect your concrete mixture quality, and then developing a quality plan and periodically auditing that to make sure that that quality plan is being followed. We have the issue of selecting the right materials. This selection of a supplier should be based on quality and uniformity of the product that they supply and the service and support, not necessarily only on cost. Suppliers, collect your material supplier certification, keep those on file periodically, look at items on that certification to verify that these things are not changing a lot because they have an impact on your concrete quality. You might choose to do periodic testing of these materials or ask for information from the suppliers about their uniformity from their source. The charts on the right, the one on the top is a variation of cement as being supplied from a cement supplier. And as you can see, the cement strength does vary with time, and that variation can cause a variation in the concrete strengths. The chart on the bottom evaluates the uniformity of the grading of an aggregate source over time, and you can see how that varies with time. Naturally, a significant variation of the aggregate grading can impact whether that mix comes together well. So take a look at these types of resources that you might need to track in terms of monitoring the quality of your suppliers of the materials that you're using. You then develop mixtures. The process of developing a mixtures can be an ACI process where you develop a 3-point curve varying the water cement ratio or the cement content, and then establishing these relationships for different types of mixtures that can include fly ash, can include air entrainment, and understand the impact of air entrainment. Whenever someone says, I want a 4,000 PSI mix, you naturally have to over-design that in accordance with ACI to develop a mix that has a higher strength so that you have a low chance of having test results that will fail the strength acceptance criteria. Many producers evaluate cement efficiency in PSI per pound. Take a look at that, see how much strength you're getting per pound of cement you use in your concrete mixtures. Understand that every 1% of air that you add to your concrete reduces your strength by 5%. So try to get an idea of the impact of entrained air on the performance of your concrete. Eventually, what you want to do is to optimize and minimize the cementitious material content and minimize the amount of over-design that you produce for a specific type of project. You have to develop submittals for projects that have specifications also. So this is an important factor or part of developing mixtures for different applications. Specifications and orders can vary, and it's important that the person receiving the order understands the details of what's required for the concrete. That could be the salesperson or the dispatcher. Identify all the requirements in the orders and specifications, whether there is not only a strength requirement, but whether there are other requirements such as a maximum water cement ratio, a minimum cement content, any limitations on the materials that you can use in your mixture. Obtain a copy of your specification to ensure that you know all those details. Also make sure that the specification is achievable. Make sure that the requirements are consistent in terms of the slump requirement, the air content requirements, and if there are problems, make sure that there's a communication through the contractor to the designer to correct something that may not be achievable. In many cases, you have to develop mixes and strength test results by a 3-point curve process. You may have to develop test data for some additional tests such as shrinkage, durability type testing, alkaline aggregate reaction. You might have these resources in-house. Generally, you might have a strength testing machine, but often you may have to use a third-party consulting lab for these services. Make sure that you choose a lab that is proficient, that can give you the right support, and that is qualified to perform this testing that you will use for the data needed for submittals. This concludes part 1 of this presentation. Look for part 2, where we'll go into some more details on quality control activities related to operations and monitoring test results and other information to manage quality.